Welcome back, guys. Today we're going to talk about something really fascinating, something I'm doing my PhD in, something that I find truly exciting. Brain-computer interfaces. Detecting your thoughts with devices like this and translating into commands machines could understand. And this is not something of the age of sci-fi, because you can see there are devices out there already, although in very primitive forms. But people like Elon Musk with his company Neuralink, Facebook Reality Labs, they're all exploring neural interfaces as future forms of input to augmented and virtual reality. Let's explore what this technology is about in this video. I'm going to take this out for now, just so you can see. This is a device called Muse, example of a brain-computer interface. Hope you can see. And I'll just place it here. So what are brain-computer interfaces? Well, it all starts with the human brain, a fascinating piece of organ situated right between our ears, weighs about 3 pounds, has 100 billion neurons zipping back and forth to form what we call consciousness, control our movements, and control everything in our lives. You can think of these billions of neurons as its own self-contained city. They emit echoes in the form of electrical activity, and that's what you can measure in the scalp. And what that means is if someone could listen to those echoes, those electrical echoes, using say a microphone or a device or a sensor, that means we could interface our minds and our thoughts with the outside world. And that's fascinating. You're having an interface directly to your mind. And that's exactly what Hans Berger did in 1924. As a child, he was fascinated with astronomy. And it's strange, instead of exploring the outer world, the outer universe, he ended up exploring the inner universe. What he did was in 1924, he detected the EEG, electroencephalogram. I still can't pronounce it to this day, even though I've been working on it for the past 4 years. So the EEG is essentially the electrical activity that emits from those neurons deep inside your brain and what's detected out there in the scalp. And you can measure that using sensors placed on your scalp, sensors placed all around. So the device that I showed you earlier, if you notice, it has 1, 2, 3, 4, about 4 sensors in the forehead. So when you put it in your head, it detects those electrical signals from the foreheads. So the brain emitting those activities, it also travels and is detectable not only on the upper side of the brain, but also here, and even the ears, which I'll talk about soon. And once you measure those signals, it's very raw and messy. How can you know what you're thinking from those raw and messy signals? Well, that's what people have been working on for a very long time. I've been working on it too for the past 4 years in my PhD. And this is how a brain-computer interface works essentially. You detect those signals measured on the scalp, and then you use signal processing to essentially get some features out of the signals so that it's more distinct and more discriminable, if that's a word. And then once you have those features, then you pass it through a machine learning algorithm to classify between different actions. Now let's talk about an actual example. What kind of uses would this be in a virtual world, say? So BCIs could measure passively your mental state. It could measure how calm you are, how stressed you are, or whether you're sleepy or in a drowsy state. Now let's say a game, you're playing a virtual game. Having the input from the BCI is extremely powerful because the game could adapt based on your mood. Say you're super stressed and you're struggling with a certain level, the BCI could detect that and modify the game mechanics accordingly. Or if you're super relaxed and not engaged enough, again the BCI could detect that and increase the challenge of the game. These are what you call passive BCIs. Then there are active BCIs. Active BCIs is where you put in the effort, like you control the world with your thoughts. So for example, if you want to move something based on your arm movements, you could imagine moving your hands. You don't have to actually move your hands, you could just imagine moving your hands, and there'll be a certain decrease in activity in this part of your brain, which could be detected by the BCI, and in turn control, say, a UI. And this is fascinating because when it comes to virtual and augmented reality, one of the main limitations now is the UX, the UI. You typically either control with the game controllers, or things are getting a bit better with the Oculus hand tracking. And soon Facebook might release their neural interfaces, their wrist-based neural interfaces, essentially give like really high fidelity hand tracking. But the future really belongs to when you can directly interface your mind with that world. Let's actually try to picture this, how this might look like in an actual device. So let's travel all the way to say 2040. At this point there might be say a smart glass, fully AR, can do truly AR displays, just like a normal glass, sleek and nice. And within the glass, say in the frames, there might be sensors that are detecting brain activity from the ears. So that's another thing. You don't have to just measure brain activity from the scalp, you could also detect it from behind the ears. It's called behind the ear EEG. And that's way more user-friendly because you don't need to put sensors all over the scalp and look ugly. It's more discreet and more acceptable for, say, average Joe to wear. So you have those glasses, you got the ear EEG sensors stuck to the frames of the glasses to detect your brain activity, and everything, your whole digital lives would be controlled with the input from the brain and in combination with, say, probably hand movements or your voice or your eyes. And what's even scarier, imagine what Zuckerberg could do with constant access to what you're thinking. Say the device owned by Facebook detects that you're stressed for a prolonged period of time, and out comes an ad right in front of your face for a stress relieving product. So yeah, ads and privacy and all that, it could be a very messy thing when this technology fully matures. I'm curious to know what you think. First, what do you think about this technology? Do you think this will be good for AR VR, or this would be bad? Could make things worse, especially in terms of privacy? And two, do you want more content on this? Because I've got plenty to talk about this. I've been working on this for the last 4 years. So if you want more content around BCIs and how it relates to AR VR and going a bit more in depth, yeah, please comment down below and let me know.